Welcome students of Thakur Vidya Mandir High School and Junior College. Students, we are going to deal with chapter 8 Electrostatics part 4. In part 3 we have dealt with the electrostatic potential, and part 4 we are going to study about capacitors and capacitance. Let us go through the first slide, that is polarization of a polar dielectric in an external electric field. Last time I had told you that dielectrics are non-conducting substances. Two examples of dielectrics are ceramics in solid state and mineral oil in liquid state. Let me go through this slide which shows the polar dielectric in the absence of an electric field. In polar dielectric, the different tiny electric dipoles are randomly oriented, as you could see in the absence of the electric field. This happens just because of thermal agitation. But if I orient this in an electric field, you could see that the dipole moments are oriented in the direction of the field in the presence of electric field. Let us come on to the various factors which are felt by the polarization. Reduction of the electric field due to the polarization. When an dielectric is placed in an external electrical field, the dipoles get aligned. The second example shows that an induced charge on the dielectric establishes a polarization field in the interior. The net field, that is the E naught, is a vector sum of E and E naught. And the induced dipole moment disappears if I remove the field. The best example of this could be seen in a charged comb and the bits of the paper. So overall, I could say that the reduction of the dielectric field due to polarization is evident by all the four examples which have been cited over here. Students, let us go through the concept of the capacitor. A capacitor shown out here is formed by the two conductors. As you could see in the figure, there is one plate which is showing a positive charge and the other plate which is showing a negative charges. The potential felt on the first positively charged plate is given by V1 and the potential felt on the negatively charged plate is given by V2. The potential difference V is the work done to carry a unit positive test charge from the conductor 2 to the conductor 1 against the field. Therefore, the formula clearly indicates that capacitance is the charge Q divided by the potential V. The constant C is called as capacitance. Let us proceed to the principle of a capacitor. The capacity of a metal plate is increased, that is the P1 is increased by placing an identical earth connected metal plate near it. If I connect this, such an arrangement is called as capacitor. It is symbolically represented by the sign which is shown out here in a dark blue line. Students, let us go to the capacitors in series. Here you could see that three capacitors are placed in parallel with each other, but this we say that it is placed in series. How is it possible? You could see that the plates P1, P2, the plates P3, P4 and the plates P4 and P5, which are denoted by plus Q, minus Q charge, plus Q and a minus Q charge. The lastly with a plus Q and a minus Q charge showing the voltages V1, V2 and V3 respectively. Let me just show you the derivation of this, that is capacitors in series. When I consider the potential difference across the series combination of the capacitors in volt, my volt is represented by a capital V and the total voltage is given by the voltage V1 plus V2 plus V3. Now let us represent that V is equal to the charge divided by the capacitance C1 plus charge divided by capacitance C2 plus again the charge divided by the capacitance C3. Since the charges are same, the charges are not numbered as Q1, Q2 or Q3. Let us represent CS, that is the capacitance in series, called as the equivalent capacitance by the formula V is equal to Q divided by CS. If I just substitute these values in the upper equation, that is V is equal to V1 plus V2 plus V3, I would be getting V written as Q divided by Cs, that is the capacitance in series, which is equivalent to Q divided by C1 plus Q divided by C2 plus Q divided by C3. So if I overall divide this equation by Q, my Q are cancelled in both numerator and denominator, and the final expression that I get is 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Therefore, I conclude that an equivalent capacitance of n capacitors is equal to the sum of its reciprocal of individual capacitance. The last topic of this chapter is parallel combination of capacitors. As you could see in the diagram, students, the capacitors are connected between two common points or junctions, and these are said to be connected in parallel. If I take the three capacitance C1, C2 and C3 of three parallel plates formed by parallel metal plates A and B attached at a common junction, in case of the parallel combination of capacitors, the potential difference across each capacitor is same. That is why it is written with a capital V. In other words, the charge Q flows to the junctions at the different points and is distributed as Q1, Q2 and Q3. This is very clearly evident from the diagram given over here. Let us proceed to the derivational part of parallel combination of capacitors. In this combination, all the capacitors have the same potential V. The total charge Q can be written as capital Q is equal to Q1 plus Q2 plus Q3. But we know that Q is equal to C1V plus C2V plus C3V. As we know, the charge is product of capacitance and the potential difference across the two charges. If I take Cp as the equivalent capacitance of the combination, then my charge is given by Cp multiplied by V. Therefore, the capacitance in parallel multiplied by V is written in the substituted form as C1V plus C2V plus C3V. If this equation I wholly divide by V, my V gets cancelled both in numerator and denominator, and what I get is Cp is equal to C1 plus C2 plus Cn. Thus, my capacitors in parallel indicates that it is nothing but the summation of all the capacitance across the charges. With this, we complete the topic for the capacitance and the capacitors. One more part is remaining, which I would be dealing in part 5 of the electrostatics. Let us proceed to the assignment questions given out here. The assignment questions are: what do you understand by the polarization of dielectrics in an external electric field? What do you mean by capacitors? Define capacitance. Derive the capacitance of conductors in series. Derive the capacitance of conductor in parallel. For the reference, students, you have to refer e-textbook as given in the link out here. Any doubts? It would be cleared with the numericals when solved in the class. Thank you.